Hello out there, welcome to this tutorial. In this video we'll be looking at change of subject of formulae. The change of subject formulae will be treated like equation where we solve for a particular variable. Like in equation, we have to find the value of a given variable represented in the equation. So the same thing here, we have several variables. A particular variable will be made the subject of the formula. So what we do is we solve the equation until we have the variable to be changed into the subject of the formula to be equal to other variables in the formula. So we are going to start with our first problem. For problem 1, make x the subject of the following formulae. We have problems A, B, and C there. So starting from problem 1a, to make x the subject of this relation, we are going to bring this y to the left hand side. So this is positive y, so we still maintain our z. The positive y here, on coming to the left hand side, it becomes negative y equal to x. This can still be written as x equal to z minus y. So we go to problem 1b. For problem 1b, we have ax minus by equal to cz. So in this problem, we are going to take the negative by to the right hand side. So taking negative by to the right hand side, we will be left with ax, and on the right hand side we still have our cz. Then this is negative here. On going to the right hand side, it becomes positive. So now we are still left with ax on the left hand side, and what we need is only x. So to remove the a there, we are going to divide both sides by a. So dividing ax divided by a, will be left with x equal to cz plus by over a. And with this, we have made x the subject of the formula in problem 1b. So we go to problem 1c. For problem 1c, we have a into x minus y equal to b into x plus y. So what we do is we are going to expand the brackets both on the left hand side and the right hand side. So we use the a outside this bracket to multiply every term inside the brackets. So we have a times x gives ax, a times negative y gives negative ay, and on the right hand side we use the b to multiply every term inside the brackets. So b times x gives bx, and b times positive y gives positive by. So we group the terms with x on the left hand side, depending on how it is convenient for you. If you like, you can group the term with x on the right hand side, so it doesn't matter. So here conveniently, we are going to take this negative ay to the right hand side and bring this bx to the left hand side. So we now have ax minus bx. This bx coming to this place becomes negative bx equal to ay. I have taken this negative ay to the right hand side. It becomes positive ay then plus by. Then on the left hand side, we are going to factor out x. So x is a factor. So ax divided by x gives a, and negative bx divided by x gives negative b. So we factorized the left hand side. We might not need to factorize the right hand side. So we still have the right hand side ay plus by. Now we need only x here. Therefore we are going to divide both sides by what we have inside the brackets on the left hand side, so that we now have x equal to ay plus by over a minus b, and we have successfully made x the subject of the formula in problem 1c. And that is the end of solution to problem 1. We go to problem 2. For problem 2, we are also to make x the subject of the given formulae from A, B, and C. So starting from problem A, in problem 2a, we have z squared equal to x squared plus y squared. So I am going to move this y squared to the left hand side, and for your information, the sides can be interchanged at any time. So if I like now, I can have it as x squared equal to z squared minus y, or I will still keep my z squared here and bring this y squared to the left hand side. It becomes negative y squared is equal to x squared. I have moved this y squared to the left hand side to become negative y squared. Now we are going to remove this square. To remove the square is to find the square root of both sides. So finding the square root of both sides, I have x equal to square root of z squared minus y squared. And that is the end of solution to problem 2a. Please, for your information, this z squared and y squared cannot be cancelled by the square root. So they cannot be cancelled by the square root. So that's the end of that. We go to problem 2b. For problem 2b, I have a squared x squared minus b squared y squared is equal to c squared z squared. So what we are going to do here is we are going to take this b squared y squared to the right hand side, so that we'll be left with a squared x squared on the left hand side to be equal to c squared z squared plus b squared y squared. So taking this to the right hand side, it becomes positive. Now we divide both sides by a squared. So dividing both sides by a squared, I have x squared on the left hand side equal to c squared z squared plus b squared y squared over a squared. And again, to remove this square, we are going to find the square root of both sides. Finding the square root of x squared, we have x equal to square root of the right hand side. We cannot apply the square root on the numerator, but we can apply it on the denominator, since it is just a squared. Since square root of a squared is a, we can have our final answer to be square root of the numerator alone over a. I have found the square root of a squared to be a, which gives the final solution to problem 2b. So we go to problem 2c. For problem 2c, I have a equal to square root of x plus y. To remove this square root, we are going to square both sides, because our x to be made the subject of the formula is inside the square root. In order to bring it out, we have to remove the square root by squaring both sides. So a squared here on the left hand side, and if you square the right hand side, you'll be left with ax plus y. Now we are taking this y to the left hand side, so we'll be left with a squared minus y. So that is the end of solution to problem 2. Now we go to problem 3. For problem 3, make x the subject of the following formulae. So in this case, we'll be dealing with fractions. We start with a. For problem a, we have m equal to x over y plus x over z. We are to make x the subject of the formula here. So what we do is we are going to resolve the right hand side into a single fraction. So resolving it into a single fraction, we have m equal to, their denominators are y and z. So the LCM of y and z is yz. So we say yz divided by y gives z, multiplied by x gives xz, then plus yz divided by z gives y, multiplied by y gives xy. Now at this stage we are going to cross multiply. At the initial stage, cross multiplication is not allowed. You can't even cross multiply there. So the only form with which you can cross multiply is when you have one fraction here and one fraction here, or you have a single term, non-fractional term here and fractional term here. Single, then you cross multiply. So I can cross multiply here. Cross multiplying, I have xz plus xy equal to myz. So I am interested in making x the subject of the formula. So there is x here, there is x here, so we factor out x. So zx divided by x gives z, xy divided by x gives y, equal to myz. Now we divide both sides by what we have inside the brackets. So the left hand side will be x equal to myz over z plus y. And that is the end of solution to problem 3a. For 3b, here again we are going to make the left hand side here a single fraction. So LCM is x. So we now have y equal to x as the LCM. X divided by x gives 1 times m gives m, minus x divided by x gives 1 times n gives n. So I now have y equal to m minus n all over x. So I can cross multiply again. So I have xy equal to m minus n. So dividing both sides now by y, we have x equal to m minus n over y. And we have made x the subject of the formula in problem 3b. So we go to problem 3c. For c, we have m over x plus m equal to n over x minus n. So what we do here, we are going to cross multiply directly, since there's one fraction on the left hand side, one fraction on the right hand side. So cross multiplication is perfectly suitable for this problem from the beginning. So cross multiplying, I have m into x minus n equal to n into x plus m. Then we now expand the brackets, collect the terms with x together, then we simplify and we are done. So we have mx minus mn equal to nx plus mn. So this term with x, this term with x will bring them to one side, and the term without x to another side. So we now have mx minus nx is equal to mn plus mn. Here x is common again, so we are factoring out x. So we now be left with m minus n equal to 2mn. mn plus mn gives 2mn. To make x the subject of the formula, finally, we divide both sides by what we have inside this bracket, that is m minus n. So if we divide the left hand side by m minus n, we'll be left with x equal to 2mn over m minus n. And that is the end of the solution to problem 3. We go to problem 4. For problem 4, make V the subject of the relations. So we have somehow compound or complex fractions here to deal with. That is not going to be a serious problem. So we have to make V the subject of the relations. So we are starting from A. To start from A, now to make V the subject of this relation, what I will do is I will make 1 over V singly on one side, and that will give me 1 over F minus 1 over U is equal to 1 over V. So I brought this here. So now I make the left hand side now a single fraction. So making it a single fraction, I have 1 over V equal to LCM of F and U is FU. FU divided by F gives U, times 1 gives U. FU divided by U gives F. So times 1 give F. So we have minus F. Now we can easily cross multiply. Wow, no, we can take the reciprocal of both sides. Yes, if we take the reciprocal of 1 over V, you'll be left with a V. Beautiful. And take the reciprocal of this, we are going to have it as Fu over U minus F. Beautiful. That's a very quick and fast response to that. But cross multiplication will still give you the same result, but this is faster and it is only applicable to this problem. Please, it might not work for other problem. So now we are done with problem 4a. We go to problem 4b. For problem 4b, V is on this term and is the fraction. So what we do is we maintain P on the left hand side and bring this 2u to the left hand side. It becomes minus 2u equal to 3w over V. Now I can cross multiply. If I cross multiply, I will be left with V into P minus 2u equal to 3w. I then divide both sides by what is inside these brackets. So V will be equal to 3w over P minus 2u. And that is the end of solution to problem 4b. I go to problem 4c. For problem 4c, here it is better I move this term with negative to the left hand side and take this y to the right hand side. So I'll be left with 4u over uv minus w is equal to 3 minus y. So having done that, I can quickly cross multiply. Yes, yeah, it's cross multiplication. So if I cross multiply, I will now have uv minus w into 3 minus y equal to 4u. I expand, so I pick the first term in this first bracket to multiply every term inside the second bracket. Uv times 3 gives 3uv. Uv times negative y gives negative yuv. And I pick this negative w to multiply every term inside the brackets here. So negative w times 3 gives negative 3w. Negative w times negative y gives positive wy equal to 4u. So what we do is we are going to move some terms to the right hand side and leave only the terms with v on the left hand side. So this term has v, so I have 3uv minus yuv, and this is equal to 4u plus 3w. This is negative 3w getting to the right hand side. It becomes positive, then minus wy. So now I factor out v, so v is common. 3uv divided by v gives 3u minus yu. If you divide by v, this v will go, you'll be left with yu equal to the right hand side. Now we divide both sides by what we have inside the brackets. So it's going to give us v equal to 4u plus 3w minus wy over 3u minus yu. And that is the end of solution to problem 4. And we proceed to problem 5. For problem 5, if v squared equal to u squared plus 2as, express u in terms of v, a, and s. So this is another way of telling us to make u the subject of the relation here. So in this case, we are going to have our v here on the left hand side and take this 2as to the left hand side, which becomes minus 2as, and we still have our u squared on the right hand side. Now we are going to remove the square on u by finding square roots of both sides. So finding square root of both sides, I'll be left with u equal to square root of u squared minus 2as. And that's the end of the solution to problem 5. As simple as that. So we go to problem 6. For problem 6, the volume V of a solid spherical object of radius r is given as V equal to 4 over 3 pi r cube. Make r the subject of the formula. What I will do here is quickly, this can be written as 4 pi r cube all over 3, so that when we cross multiply, we'll be having 3v equal to 4 pi r cube. We're interested in r cube, so what we do is divide both sides by 4 pi. So we now be having r cube equal to 3v over 4 pi. Now to remove this cube on r, we have to find the cube root of both sides. So finding cube roots of both sides, we'll be left with r on the left hand side equal to cube root of 3v over 4 pi. And that's the end of solution to problem 6. We've made r the subject of the formula. So we go to problem 7. For problem 7, we have to make L the subject of the following formulae. Starting from problem A, we start from problem A. For problem A, in order to remove this square root, we are going to square both sides. Squaring both sides, I will be left with m squared equal to n squared plus 2al. The square, we remove the square roots. Now I am to make L the subject of the formula, so I am moving this n squared, so that we now have 2al equal to m minus n squared. M minus n squared. So we then divide both sides by 2a, so we will now be left with L equal to m squared minus n squared over 2a. And that is the end of solution to problem 7a. We go to 7b. For 7b, this 2 pi is not connected to the square roots, so we are going to divide both sides by 2 pi. So we'll be left with t over 2 pi equal to square root of L over g. Now we need to remove the square root by squaring both sides. Squaring both sides, we say t squared over 4 pi squared. Square 2, we have a 4, square pi, we have pi squared, equal to squaring the right hand side, we have L over g. Now, since we are to make L the subject of the formula, Let us cross multiply. Oh no, we can multiply both sides by g. If I multiply this one by g, g will go, I'll be left with L. Multiply this one by g, I will have gt squared over 4 pi squared. And that is the solution of problem 7b. Then we go to 7c. For 7c, immediately I have to remove the square root on the right hand side by squaring both sides. At that point, I'll be left with y squared equal to L minus h over LH. Now I cross multiply. Cross multiplying, I have LHY squared. LH multiplied by y squared gives LHY squared equal to L minus h. I'm bringing this h to the left hand side because it is negative, and bring this to the right hand side. So I have h equal to L minus LHY squared. Now we are looking for L. There's L here, there's L here, so we factor out L. So we have L into L divided by L gives 1 minus HY squared. LHY squared divided by L gives HY squared equal to H. Then I now divide both sides by what we have inside the bracket. So we now have L equal to H over 1 minus HY squared. And that is the end of the solution to entire problem 7. And that's the maximum we can take in this tutorial. Please subscribe to our YouTube channel. Check the description section of this video for more problems on change of subject of formulae. If you have any problem, you can place it on the comment section of this video. We'll attend to your problem. Until I come your way again, goodbye.